Wharton, going into the horizontal well world.
The big button. That's my pointer. All right, good to go. All right, good afternoon, everyone. My name's Alyssa Wharton, and I'm a project engineer with NREX. And today I'm going to be presenting on the life cycle cost advantages for using nested horizontal wells, comparing that with typical treatment technologies. There we go, at active sites. And the technology I'm presenting on is the vertebrae well system. Oops, there we go. So some things I wanted to point out before we really get going. We have to make some assumptions when I'm talking about life cycle costs today. So I wanted to talk about the purpose of today's presentation and what we're going to be looking at. So really trying to provide concepts and items where we have observed value added and cost savings with vertebrae well system installs. And it's not really to provide hard costs for the comparative technologies, because we know that can be highly site specific and really variable. We will get into those costs, but not a general hard cost. Some things that we're not examining but are important to keep in mind that we saw value added but couldn't put a price tag on. Added safety. Our drilling is with automated drill rigs. We're able to do that out of the way, out of harm's way, avoiding business disruption, something that adds value for our clients but doesn't necessarily have a price tag on it. As well as adding value to our site conceptual model and being able to grab samples, additional monitoring. So we're not getting into details with that today, but just something to keep in the back of your mind. Okay, so vertebrae well system, our nested horizontal well, nested meaning segmented or screened. And those each have individual risers that are running up to the surface and installed using HDD technology. And we put in a grout seal in between each of those to keep them discrete. The figure shows 7. You can do 20, you can do 3. It's really about how much control you're looking to get for your specific site. The main benefit is being able to, adjust for preferential flow like we show in this figure, and that can be with extraction, injection, or sparging throughout different lithologies. This table summarizes different technologies that our wells have been implemented with in different areas of the country, from air sparging, ISCO, which is kind of where we got our start, different vapor mitigation, down to some pretty cool PFAS flex studies using sensors that were installed in our wells with grabbing samples from that. I'm going to go through 5 different technologies and focus on ones where we were able to grab a good cost matrix to further examine. So we can use or be implemented for a wide range of flows, looking for low flow or injection or ozone, up to more high flow, air sparging, SVE, and that can be customized. If you see these different size risers, that's what's coming up out of the ground and connected to each well segment. So depending on what sizes we use, can customize that total flow for the system you're looking for, dependent on your site. So the first site is a biosparging site in Florida, and this one's pretty interesting because they are rolling out in phases. The first phase was here on the left, phase 2 on the right, and they're getting ready for phase 3 in the next quarter. So we installed 3 vertebrae wells up underneath a metal building, and the design was based on a pilot biosparging test they ran vertically, so that's what we based our spacing of our systems off of. And after running their biosparge system for a while, they realized that we were outperforming that original ROI that they saw to about 2 to 1. The original 10 feet was now closer to 20 feet. So we had 2 options going forward. we could install the same original design and just have a more robust treatment and hopefully expect the system to clean up faster and save cost on that. Or we could adjust our system, which is what we did here, spaced them out, and we're able to save on the install and install fewer wells. So for our comparison, wanted to show you guys a vertical bio layout. And this is, again, using their pilot data that they grabbed for us, and using that 10-foot ROI, we spaced it out to cover the exact same footprint as the vertebrae wells. We are making some assumptions that we can drill in that metal building under the roadways, but we wanted to give you guys a equal comparison, equal coverage. And using our consultants' SPI rates, we costed this out, including the trenching back up to the system. So, oh, nope. There we go. I'll get that right next time. For our cost comparison, with that even coverage, we're assuming the system should run the same amount of time. So assuming 3 years run time, that's going to cost $360,000 in system, same for both. So really we're looking at the difference in install. Vertebrae phase 1 was $105,000, phase 2 $121,000, for a total $226,000 for those 6 systems I showed you. And for the 76 wells vertically and all the trenching came out to $342,000 or so dollars. And again, that was using our consultants' SPI rates they get. And that worked out to a cost savings of 16.5% over the life cycle of the project. Just really wanted to show you guys kind of how we think through this. So if you're trying to compare horizontal versus vertical, give you some different things to think about. And really the exercise is to carry this through the full life cycle of the project. Our next site up is also in Florida, and we used ISCO treatment out here. As you can see highlighted in the yellow is how much of the plume was off-site, so about 90% or so. And really horizontal was our only option because the off-site owners were adamant that they did not want any trenching, no disruption in their parking lot or closing of the roadways. So really horizontal was our only way to go, but I will show you guys a different layout for comparison's sake. So we went in with 4 systems. The first one was installed for a pilot test, and then they went back in and installed the additional 3 for a full-scale design, which included 25 total segments. And this was used for ISCO. Over the project, they injected 21,000 gallons of reagent into those segments. And after 6 quarters, they were able to go into PARM. The last couple quarters were actually targeted to the back. We had like 1 or 2 wells that had some recalcitrant contamination, so we're able to shut everything else off and just inject into these few segments back there, went into PARM, and then got closure 3 years after install began. So for our comparison, we wanted to look at DPT. That's a ISCO technology that many of us use on sites in Florida. And using our soil and ROI data we had from the consultant, went ahead and came up with spacing these out on 10-foot centers and getting full plume coverage, came up with this nice layout of 190 total points. And we're assuming the same effectiveness as the vertebrae wells, so injecting the exact same amount of chemical. And then we're also assuming that we would experience that same recalcitrant area. Oops, keep hitting that leaf. So 1 large event to blanket the entire plume, and then came back with 2 additional events to hit that area. So let's take a look at those costs. So we have some savings we see on oversight as well as in the overall install and injection effort for 14% savings. And this one just wanted to point out the efficiency of our install, can save you some time on site, and time saved also equals cost saved. Next up, we're leaving Florida, taking you guys to Colorado. This is a Airsparge SVE site. that was installed on an active gas and resale station, had El Napple before they started running the system. And we were able to install this full array from behind the building and avoid any business disruption. As you can see, the majority of the plume, whoops, sorry about that, was under this highway, high-speed highway. So again, horizontal was really the way to go. They weren't going to be able to get any vertical wells in that area. And we exited out in all these right-of-ways on other properties, so no one was the wiser. I didn't know what was going on site, kept our business owners nice and happy. They ran the system for 3 quarters and adjusted it as the plume shrank. After 3 quarters, everything was below detection limits. They ran an additional quarter to make sure it stayed that way, went into PARM, and received closure 2 years ahead of their estimated schedule. So for the last 2 examples, kind of showed you guys the full scale, full plume coverage examples to be equal to our vertebrae layout. But this one we wanted to think, what if they went vertical, just went where they could go, and kind of dealt with the consequences of that. So this is the original layout that the consultant had before they decided to go horizontally. It's addressing only on site where they can drill, so we're not getting under the canopy, not addressing in the roadway at all, and just kind of seeing what happens. So it makes our cost comparison a little difficult. We'll talk about some of the assumptions we made, but the vertebrae install was a little over $500,000, and then with the system O&M, all in, a little over $650,000 took them to closure. Now vertical, much cheaper, but again, they are covering about 30 to 40% of the plume, not getting that full coverage. So how did we estimate this system O&M? Their original estimate was 3 years with our vertebrae, so that's kind of what we can assume our best case. You see that lower range total there. Could it take 6 years? Could it take 9 years? We really can't say. Who knows how long that could continue seeping out from under the roadway, how long it would take that flux to equilibrate. But is that a risk you're willing to take? The cost savings we're estimating in that middle range would be about 15%. Could be much greater if we start creeping up into that high range. So just something to think about, getting that full coverage. Next up is vapor mitigation site in California. No, we don't do a lot of this in Florida, but these principles can carry over to other technologies, so stick with me. This was a brand new apartment complex that had an existing hydrocarbon, chlorinated hydrocarbon plume on site that they just did not take into account during their construction activity. So we came in afterwards. Again, the complex was completely built, so wanted to go in horizontally. We installed these 6 legs, all blind, some of them from the parking garage. It was a pretty interesting install. But we're able to cover all those units, and they are running 4 vapor mitigation blowers right now to target any potential vapor intrusion. So what would we compare that with? We decided to look at our conventional horizontal engineered wells. Again, vertical just didn't seem like it would happen, but this would very well be a really great option. Could go along the exact same bore paths, give us the exact same coverage with long continuous screens, and can be installed for virtually the same cost. So brings us to the idea of what really is the difference. With vertebrae, like I mentioned earlier, we have the benefit of added control and discrete sampling. So this is more of an intellectual example I wanted to show you guys, and a few different things to think through. But say, what if we were able to, or what if we did grab samples at the beginning of this install and saw that treatment wasn't necessary in one area of the building? We could turn down our blowers, or something was really hot and we could target that area better, run our systems more efficiently. On the other side of that, once we have the traditional horizontal engineered wells in there. It's pretty limited on its modification abilities. So you're going to expect to pretty much run your systems full the entire time of the project. And that brings me to the other thing I want to think about, preferential flow. Again, vertebrae, we can control for that by turning up or down individual segments, long continuous wells in order to make sure we maintain that vacuum across the entire screen. You're probably going to have to turn your blowers up, give you a little additional power use. So over 30 years, again, this is just a vapor mitigation. It's meant to be ran continuously with the blower specs from our client on their current California electrical rates. Might look a little higher than Florida. $400,000 to run those 4 blowers. What if we were able to turn one of them off because we were running more efficiently or just didn't need to run it in certain areas? You could save $100,000. So again, this was more of an intellectual exercise, but just wanted us to think past just the installation and some other ways that could lead to cost savings. Our last site is a site in Philly, and it has been operating a groundwater collection trench since 1999. So for over 20 years, that was their main form of remediation to ensure that their on-site VOC plume wasn't migrating off-site. After 20 years, they decided that they wanted to kind of think through some additional things they could do to handle this problem. They were periodically able to turn off the trench because on-site and off-site wells were below limits, but they would start to see the off-site wells creep up, getting up to like 2,900 parts per billion toluene. So the trench was going to be running indefinitely. Also, the on-site well, even when the trench was off, was remaining clean. So they're like, maybe the issue is actually under that roadway. Let's see what we can do there. So we came in, installed vertebrae down the middle of the road, 8 segments, and they went ahead and grabbed samples from there. We're not prepared for what we found, which was toluene at 68,000 parts per billion under the roadway, much hotter than their off-site wells were showing when they were getting their spikes, and it was right along the sewer there. So I think it's important for us to note that where we have utilities under buildings, under roadways, where pathways have been dug up and backfilled, they're really susceptible areas for the collection of mass, which is what happened here. But now that the vertebrae was in place, they had the tool they needed to treat that problem directly. Oh yeah, and I didn't mention, over the past 20 plus years, they had spent over $1 million running that collection trench. So our cost comparison, the vertebrae was $84,000 to put in, and they've since done some bioamendment treatment in it for $150,000. Seeing some really good results from that, some nice knockdown of the toluene. But again, at those high levels, we're expecting them to still take a little while to get that under control, but estimating that within 5 years, they should reach their cleanup goals. If they continued running the trench, for this example, we're assuming another 10 years of operation, but again, they've already been running for 20 and still have the same problem. So I think that's going to be on the low end, but that would be $500,000 per decade. So expecting, now that the vertebrae is in place, at least a 50% cost savings over that life cycle. So to summarize, we talked about 5 different sites today where we have seen added benefit. Our clients chose vertebrae for other reasons, for access issues, safety concerns, to avoid business disruption. But afterwards, we have seen clear additional benefits as well. The first site showed better influence, able to save money on well install by installing fewer wells to get the same radius of influence in cases, or even reduce our treatment timeline with more robust treatment. With our efficient install, we can save on oversight, which for some clients, that could be a big plus for them. Complete coverage. Without complete coverage, we're either really extending our treatment timeline or possibly not ever getting to our goals. We saw that with our air sparge SVE site. And then control matters, the ability to update, adjust, optimize throughout the life cycle of the project really adds to us being able to run our systems more efficiently, which does save us money. And then, last but not least, location is key. Even the best of treatment technologies, if they're in the wrong place, it's wasteful, it's inefficient, and it's just gonna look like it's not even working at all. So with vertebrae, if you find your hot spot, that's no longer a problem, and that's what we feel is our key feature here. The big takeaway today is that location is critical. Location, location, location. So that is it for today. I guess questions at the end, but feel free to send me an email or come find me in our booth if you want to chat further. Thanks.
I